The $40 million discard. The Ariane 64 stack that cleared the tower in French Guiana on April 30th intentionally dropped $40 million of flight-proven hardware into the Atlantic within 2 minutes of ignition. While the industry fixates on the landing legs of the Falcon 9, the European Space Agency just completed its second successful delivery for Amazon Leo by doubling down on an architecture that launch providers were supposed to have moved past. This flight, designated VA-268, used 4 P-120C solid rocket boosters to push 32 satellites into low orbit. It is the core of a $10 billion logistical machine that prioritizes delivery cadence over vehicle recovery. To understand why ESA chose a disposable heavy-lift configuration for their biggest commercial contract in history, we have to look at the specific thrust-to-weight constraints of the P-120C. The solid fuel compromise. Solid fuel is often dismissed as a legacy technology, but the P-120C is a monolithic carbon fiber casing designed for a specific industrial synergy. By using the same motor for both the Ariane 6 boosters and the first stage of the Vega C, Europe achieved an economy of scale that liquid systems rarely hit at low launch frequencies. Each booster provides 400 or 500 kilonewtons of thrust, but they are essentially dumb pipes. There are no turbopumps to fail, and no cryogenic management systems to scrub a countdown. For the Amazon Leo contract, which requires 18 launches on a strict regulatory clock, this simplicity is the feature, not the bug. The trade-off is a lower specific impulse compared to liquid oxygen systems. But the raw thrust at liftoff is what allows the Ariane 64 to loft 21 metric tons without the complexity of a triple-core liquid booster arrangement. The 14-ton Propellant Delta. Arianespace is already moving to phase out the P-120C in favor of the P-160C, which finished qualification testing last year. This upgrade is not a design overhaul. It is a literal stretch of the existing casing to hold an additional 14 tons of solid propellant. This specific delta increases the payload capacity by nearly 2 metric tons for mega-constellation missions. For the Amazon contract, that means more satellites per fairing and fewer launches to hit deployment targets. In an era where launch slots are the primary bottleneck, increasing the propellant loading of a flight-proven booster is a higher probability path to success than attempting to master the thermal stresses of a reusable first-stage reentry during a high-cadence ramp-up. The Reusability Shadow Project. While Ariane 6 burns through hardware, the Themis demonstrator is currently sitting on a pad at Esrange, Sweden, waiting for the spring thaw to attempt its first 100-meter vertical hop. This is Europe's move toward a liquid methane Prometheus engine, which targets a production cost of €1 million, roughly 1/10 the price of the current Vulcain 2.1. However, the engineering reality is that Themis is years away from the high-energy trajectories required for heavy-lift missions. ESA is effectively running a two-track strategy, using solid fuel disposables to secure the immediate commercial market through 2026, while treating reusability as a research and development project rather than an operational necessity. It is a cynical, but technically sound, acknowledgement of their current infrastructure limits. The logistical pivot. The success of the VA-268 mission confirms that Europe has pivoted from being a center for aerospace innovation to becoming a high-volume logistics provider. By sticking with solid fuel boosters and the P-120C architecture, Arianespace has prioritized the 18-flight Amazon contract over the technical prestige of reusability. This isn't a failure to innovate. It is a deliberate optimization for a specific delta in the launch market where predictability is more valuable than hardware recovery. The real test of this strategy begins later this month as the first P-160C boosters begin integration for the next Kuiper batch. If ESA can maintain the current monthly cadence while Themis validates the Prometheus engine in Sweden, they will have successfully bridged the gap between legacy reliability and the methane-powered future. Watch the flight data from the first Themis hop test in Kiruna. That will define whether Europe's next heavy lifter looks more like a Falcon 9 or a refined Ariane 64. Subscribe for more